Hello, Reality Capture Network. It's great to be here. Thanks for having us. I'm DeStefano, work at DPR Construction. I'm the West Coast Innovation Leader for DPR. And the team that I'm on develops DPR's innovation strategies and processes. We lead evaluation and early implementation of new and emerging technologies. And we advise DPR's venture capital arm, WND. We do this through collaboration and partnership with internal work groups and external vendors. We strive to match DPR strategies and top challenges with our top challenges and influence the development of the tools in our industry. My focus areas in my current role align with my background in virtual design and construction and reality capture. I view the model as the plan and the reality capture data as the actual. I'm very passionate about exploring ways that we can extend the life and utility of the model and bring in reality capture to understand what's actually happening on site. So that means that augmented reality, virtual reality, 360 photos, laser scanning, photogrammetry, UAVs, mobile mappers, all of those things sort of fall into my purview, including the analysis tools that we tack on top of those. I'm also on the board of directors at the U.S. Institute of Building Documentation. This was talked about a little bit earlier, but the USIBD was created to serve our industry, and one of the ways that we do that is through standards and guidelines. The most relevant, I think, to this audience is the level of accuracy specification. We've talked a lot about this conference, about the need for standards and specifications, and I just want to let everybody know that there's one out there that exists. There's the level of accuracy specification that USIBD has two parts: the representation of what you're going to represent with your model, that's represented accuracy, and you have the measured accuracy. And I think a lot of people could benefit from using those tools. So I want to remind folks that if you go to usibd.org, you can download this specification for free, and I would love to hear your feedback, and the rest of the team at the USIBD would love to hear your feedback too. So my challenge to you is go download it. Let's try to break the internet, right? Let's see if we can break the site. So in a little bit, we're going to talk to you about how we use reality capture. Dustin's going to do that piece. And then I want to talk to you guys a little bit about some trends that I'm seeing and some future possibilities about those trends and a little bit of a call to action. So I'll let Dustin take it from here.
Okay, so take this off. Dustin, Ridley, DPR Construction. I've been with DPR for about 4.5 years now. So I'm going to try to do my best to cover all the historical details here of what we represent as a company. So we got a little bit of stats on the screen here, and I'm not going to go into detail on everything. You can read this. But what I really want to focus on is the bottom part. And what I think is significant about this is that, currently at DPR, we have 131 plus VDC professionals across our regions. And we also have 38 plus field technology specialists, and half of those have a surveying background. And we put plus behind that because that's growing constantly. It's never static. And down to the right over here, you'll see that our goal is 100% adoption of VDC on all of our projects in DPR. This is from $1 million job to multi-billion-dollar job. And what I think is significant about this is that what I'm starting to see from my perspective is that also entails reality capture. We're starting to see that in some shape or format or application that reality capture exists on almost all of our projects. And if you can see award to date, 633 is a lot of projects. So that really is the reason why we have a lot of EDC professionals at our company. So it's a lot to take on. So as kind of an icebreaker here, and I should probably do let's see if this works. Yeah, we'll have to play it. So I put an icebreaker in here. Who's been in a really sketchy laser scanning situation in their lifetime? Right? It's already looking sketchy on the screen. So the reason I put this up here is because it starts out kind of scary. And I'm going to have to warn you, there is some adult language in here. So if you don't want to hear it, put your earmuffs on. And if it's not playing audio, what's happening is there's some crickets chirping. I'm pretty sure there's an owl in there that's doing its thing. But we sent Derek out there. He's one of our VDC engineers.
Dude, this fucking place is scary.
I felt so bad for him because I asked him to go in the middle of nowhere to scan this warehouse. I was in a meeting and I got this video. And I just started cracking up laughing because I just understood what he was going through. He was there, he's by himself, it's scary. But this is real talk, this is the real world. We go out there and capture these conditions. So we can create a model out of that, get the point cloud and create the model. So the reason I showed that video is because, scary, right? That's something that's very relatable to me because I come from a trade contracting background for 11 years, 5 on the concrete, 6 on the electrical, and I thought it was like the coolest thing since sliced bread with my tools. It was very focused, Revit, Bluebeam, Trimble. I had just a few things to worry about. When I came to DPR and general contracting, my same thoughts was as Derek, is like this freaking place is scary, right? And the reason so is that there is a lot of applications out there. There's a lot of software, there's a lot of applications, and I think this is going to be kind of the theme of this presentation is the right tools for the job. And this is actually a study that's been done, but we now as general contractors use more BIM than architects, which is pretty incredible. So in thinking on that, at DPR, we use a lot of software. A lot of vendors and developers out here today, we use your products. And what we need to be able to do as a general contractor is take these products, create a baseline of what works for most of our projects, but right fit the tools for the job, whether it's design build, if it's design assist, IPD, if it's a TI. We really need to dial in what is the right recipe of tools across the construction timeline. And that's a lot of work. That was a scary venture for me to come into a GC, learn from Josh, how really the best way to apply these tools and do work effectively. So we're not just doing technology for the sake of technology. So that's going to be kind of the theme. So what I'm going to do is kind of walk through some use cases of how we use our technology. But before I do that, I want to tell you a little bit of story, which kind of will tell you how much of a nerd I am. But in thinking of right tools for a job, I think of something I've done in my own time. And moving from one house to the other, I actually took one of the Matterports from our office, and I scanned a house that we're moving into, and I exported XYZ from that to create a RCS out of Recap, and then I brought it in CAD and created a floor plan and put all the furniture in there, and I actually arranged the furniture in a way that on this U-Haul, because I actually put the U-Haul in AutoCAD as well. So I put all the boxes and everything in this U-Haul. The first thing to come out was the last thing that needed to go needed back of the house. And the last thing to come out of the U-Haul was this could be like closest to his front door. But what I did was I color-coded all these boxes with color stickers that corresponded with the CAD plan. And what I was doing was driving down labor. And when I gave this plan to the movers, they kind of looked at me like, "Are you serious?" So I was driving down their hours with some very simple tools. And really, what it was is Matterport, a little bit of AutoCAD, some Bluebeam, and Recap. Not complex. Someone asked me like, "Well, why didn't you laser scan your house?" Well, why? I didn't need to. I was able to accomplish what I needed to with a Matterport. Well, why didn't you model it in Revit in 3D? Because I didn't need to. That for what I was doing, I didn't need that technology at that time. And that's kind of the point, is using the right tools for the job. So ROI and quality evaluation. This is more of a journey for us. Going back a decade and when we started laser scanning, we've kind of gone through an evolution of like, okay, we're gonna go scan the deck, whether it's a form deck or a PT or a metal pan decking. We're gonna get a point cloud, we're gonna give it to you. And then we realized we probably should do more than that. It went from that to, well, let's build this into the schedule. Let's build quality and laser scanning into the schedule so that we have time to laser scan and do what we need to do and hand over a deliverable the next day. And let's put more energy into creating a budget that makes sense so we're not out of money when we need to do the work we need to do. So we started really focusing on that. And then it turned into, well, how are we actually giving the information to the teams? And, we've seen similar creations of this, this week with GCs creating PDF deliverables for the point clouds. But this is what we started doing. We created a PDF deliverable, 24-hour turnaround. The next morning, the MEP trades had this information. But now we're starting to see innovations, such as Avere. They automate this process, and I think that's just awesome, right? I'd like to see more automation in this world. But we started taking it a step further. It was like, well, some of the PXs might ask, like, well, what's the ROI on what you guys are doing? So we got down to literally everything that we found in the point cloud that was off from the model. We would assign a value to that with the PM and the PE. We'd sit down with them and come up with a theoretical ROM of what would have cost to fix this if we had not caught it with our laser scanning work. Now, I know that some of this would have been caught, right? So it's a little bit of an iffy study. But the point is we attempted to track this. And you can see down here, we caught about, in theory, $272,000 worth of prevented rework when we spent $30,000. The point of this is that this is going to allow us, if we do this more and more and find ways to add cost to what we're catching, we're going to be able to study this from a historical analysis. And really the end goal here is that it's not just about the technology. We need to invest in the behaviors of our trade contractors. So what I mean by that is we did this on another project. We went through all those steps. We got the PDF deliverables, and this was a 17-story building. And what I started to notice is that we're catching the same amount of issues going all the way up. And to me, catching issues with a point cloud is not really a success. The success would be catching 0 issues, right? So we really need to start having intentional conversations with the trade partners to leverage this data and information to improve performance so that we're not catching anything with our laser scans. So all in all, this is the steps that we've gone through, that we've developed for kind of a recipe for success. And the tools that we use can be a variety of different laser scanners, right? But definitely not taking a Matterport up there, right? So next example is augmented reality. This one's dear to my heart because I love this. This is an example from a large healthcare hospital. We set out to do full in-wall coordination on 1,500 wall elevations for this hospital. And when I mean full in-wall coordination, that's fully detailed framing, bottom track, top track, the devices, the furniture, if it was on the floor, in the wall, on the wall, above the ceiling, in the ceiling, we were modeling it and we were coordinating it. And what we're looking for from an in-wall overhead standpoint are these things to the left. I'm not going to read them all off, but because we went through this detailed coordination effort, it really kind of opened the door to making a decision. And the decision was, do we laser scan all the interior? And this was several years ago, so we were quite yet at the mobile scanning standpoint. So we gave a ROM for scanning 700,000 square feet of interior with one of our terrestrial laser scanners, and the team was like, no way. And I was glad that they said no, because that would have been a nightmare. So the right tool for the job, we felt, was to use our augmented reality tools, and literally, since we had this information, to overlay it to the field. And what you can see up here is that we're able to make some determinations of if things are missing, if they're out of place. It's not going to be down to the 1/8 inch of tolerance, but it's good enough for us to know if something is missing from a device. And you got to have some kind of construction knowledge to know that I'm not going to go pester the electrician for their conduit being off from the model. I may go to the modeler and say, hey, your modeling bins are a little different than what's showing up in the field. Maybe you can make an adjustment to your Revit families. But this was a much cheaper alternative to catch all that big ticket, high level items. And it really is a lot easier than folks think. But it really starts with the model and having good information to bring to the field. Photo documentation. So we do use Structure Site at DPR, and we use a lot of it. This example that we have here is from our ASU project in Arizona. We had 13,392 360 photos. That is a lot. We used it at OAC meetings. We use it to go back and check the work that we're looking at. Maybe we had questions about something we did in the past. We can message each other on the photos, add inspection notes. But what I really like about this is that I watch the data that's being tracked from everything that's being logged through Structure Site. And what what I started to see was like, okay, hey, team, we got 13,000 individual 360 photos. Maybe we can use video walk next time and save you a lot of trouble of taking 13,000 photos. And I would highly encourage using video walk because it's a much more efficient than taking that many photos, right? So really neat tool to document our project, but we also use photogrammetry. So I'm curious who's going to give me crap about the tripod on that Matterport. So I'm not traditionally a field technologist. I come from a BIM authoring VDC background. Some of the advanced field technologists in our company like to give me crap because I really like Matterport, and they're very into the mobile scanners and laser scanners, terrestrial laser scanners. So I chose to put the Matterport on the heaviest duty tripod I could find in a closet and go out and do some Matterport. But the way we've used this is that we would document milestones of construction. And we did this on a Tucson project where we would do pre-demo, after demo, framing, rough-in, different stages of drywall and completion, trim out and completion. And we socialized this as a communication tool with the owner. We created a QR code, we put it on the outside of the wall where we were doing the work, and people can walk by and scan it and see what we were doing, what we were up to. So we often said it's 360 photo documentation and photogrammetry. It's not one or the other, because there's a use case for each one of them. And down here to the left, what you're going to see there is another example of pulling an RCS out of Matterport as a photogrammetry. And what I did with that is I shared it with the design team. I could have gone and laser scanned it, but I didn't, because I didn't need to go to that extent knowing what they were after. And all they wanted to know is just like, is the boiler here? Do we have this there? Do we have that there? So I was like, let's go test this out. Let's go Matterport it, as I call it. I know some of the folks I work with hate that term. But we went in there and we did the whole scan in there, and we gave it to the architect. After we exported it to RCS, they brought in the Revit model, and they were able to very quickly see, like, oh yeah, I know where everything's at, generally speaking. It's not meant to be an actual high tolerance as built. So it's just another example of how we've gotten creative of using different tools for the job. And it's not just like we're going to scan everything at all times, right? But all these are forms of reality capture, I think, is the point. So, opportunities. This is something that is very near and dear to my heart, because I've pushed very hard for this in DPR, where we are exceeding the threshold of what is expected. This is an example of a $2 million project. It's 2 ORs. When we started this project, this 2D floor plan is all we had. We had no design model. So what we did was recreate the design model ourselves from the 2D plans. After we laser scanned it, we created the existing conditions in Revit. We put in the framing. We modeled the equipment, the boom supports. And because we have MEP folks on our team that previously were from the trade partner side, we worked with the trade partners to model their scope as well, because they didn't have the modeling capabilities. So we literally recreated this entire thing when we had nothing to start with. But the point I want to make is this all would have not been possible if it wasn't for the reality capture piece. That was significantly important to start there with exact existing conditions and build out of that so that we can coordinate very quickly. Within a 3-week period, we built this, and we were able to make a lot of improvements to this work. And these are complicated little rooms, by the way. So a really great example of like what's achievable with reality capture and pushing the needle on small projects. So, similar to what you heard earlier, I mean, we use laser scanning, reality capture for everything, even our pursuits. You were hearing that earlier. We do the exact same thing. We will go out and laser scan a whole campus because we can, and we'll recreate an entire Revit model ourselves. But what we'll do is we'll tie that to Synchro. We'll bring in the schedule, and we'll create Revit logistics. We'll create the site utilities ourselves, and basically we're building this entire plan at pursuit stage, which is much more effective to carry through the whole life cycle of the project than creating what would be considered like a Hollywood BIM model with SketchUp. But again, all that was achievable because we're using reality capture, and I think that's pretty significant. And we use reality capture for floor flatness, floor levelness, heat maps, contours, as-built conditions, pre-pours, wall contours, deflection. There's really a use for it in every application. But some areas that I'm really excited about is this. So this is a marrying of a 3D mesh from Aerial with our Synchro model. So essentially what we did is we brought this mesh into Synchro. We married up the model with the P6 schedule. And what we're starting to see is this kind of mixing of reality and real-time information. And what I think is going to be really neat is we can get to the point where this just is always updated in real time, where you have always updated mesh of the site conditions, and you always have an updated schedule. It kind of confuses the mind a little bit. I have other examples of this that really bring that home, but they're NDA, so I can't show them. But this I feel like is the next generation of merging reality capture with schedule, with planning, and we're on a project right now where we're laser scanning and flying drones every day for 3 years straight. So that's a lot of data, and that's an opportunity to be real time like this. But pretty incredible example of what some of these executions could look like in the future. Okay, I'm gonna hand it back off to Josh.
Thanks, Dustin. Really good stuff. So like I said, I wanted to talk to you guys a little bit about industry trends. I'm not necessarily covering everything. I just wanted to give you some perspective on a few things that I'm seeing. And there's been some through line with the presentations and throughout the conference this week. So does anybody recognize this? I see some hands. Does anybody know what year it came out? I looked it up, it was 86. So you guys were all pretty darn close. So if you don't know what this is the first Aliens movie that was released in 1986. It's an exoskeleton. I had to ask Dustin because I couldn't remember, but they used these exoskeletons at the loading dock, and they ended up using them as a weapon against the aliens, right? So I don't think that, when this came out, people were thinking, oh, that's going to become a reality someday. At least not too many people, right? But it's starting to become a reality. Look at the gentleman right here with the camera. He's got an exoskeleton on. We've done pilots with Hilti and their exoskeletons. Look at the NavViz, right? And pretty interesting, the story with the guy in the warehouse. We also had a fun little coincidence as we were putting this presentation together, where Dustin and I have pictures of ourselves wearing the NavViz, but the folks that are using them on our jobs, they're not running around taking selfies. So we didn't have any pictures of our teams using it. And we're in our room prepping our presentation, and one of our colleagues calls and says, hey, look, I'm using the NavViz. He's out there scanning. So this is life imitating art, right? We're seeing sci-fi in real life at this point. So this sort of helps illustrate my first point about some of the trends that I want to talk about. And the first one is that consumer and entertainment technology, including other industries really, are really pushing to influence our industry. I think the expectations from the next generation are going to be really, really high. And we need to understand that there's a huge gap between our consumer tech and our professional tech. I believe it was John from EIS, the first day, he said that people were using 30-year-old technology in their professional lives or at work, and then going home and using state-of-the-art iPhones. We really need to close that gap, right? Folks today can jump into Fortnite, dress like a dinosaur, and go see a concert, right? They're going to expect that same kind of feature-rich idea, like of going somewhere and reviewing something or converging on an island with 100 different people. They're going to expect that in a model for design review, for construction, for planning, that kind of thing. They're going to expect the same kind of technology. I also think that we're going to see alternate capture methods with the advancements in robotics, automation. We've seen a lot of that in the conference today, but also with an idea that I'd like to call passive capture, essentially bringing taking the human out of it. There's a company called Loris that I'm really interested in. We did a pilot recently and got some good feedback. But this company's created a temporary lighting beacon. They call it the Loris Beacon, that includes temporary lighting for the job site, 2 weeks worth of power, temporary power right at your fingertips kind of thing, and then adds Wi-Fi and a camera, and essentially gives us the concept of being able to push a button and capture information about the job from anywhere. That's pretty darn exciting to me. The fact that we can do that and we'll be able to, in the future, combine passive capture with active capture and sort of figure out what the right tools are for the right job kind of thing. I'm also really excited about this because it solves the problem of connectivity on the job site. I don't think we've seen a really good solution to that, and that would solve some data, transfer challenges and things like that. I'm not going to spend too much time on Spot. I'm a dog person, but I wasn't really excited about Spot when he came out. Now I'm excited because he's beginning to do things on his own. And I really think that's exciting for us in reality capture with the labor shortage and all those kind of things. And it's a really interesting combination of reality capture, automation, and robotics. So I think there's been a lot of milestones reached. You see Leica, you see, I think this company's called Computer File or something like that. Adding reality capture devices to, the robots and letting them go on their own. This is another example of that. This is a team that went to do a video from a team that went to do this subsurface challenge from DARPA. And they've got some really cool, interesting stuff on here, but basically what you're seeing is like all different types of robots, right? You're seeing ones, roll around, some with tracks. There's one coming up that I think is a hybrid that flies and rolls. And so, there's a trend toward like not just what we're seeing right now. Like there's a possibility that we would have lots of different robots. And speaking to other industries influencing us, like a lot of this is driven by space exploration. Like this is essentially what these folks are trying to do, is create the Prometheus scanning situation, right? Be able to go to somewhere else, the moon, another planet, or whatever, and be able to blindly go through and map a space. And pretty interesting what's coming out of that. So I think there's a lot of interesting stuff coming out of the research, both in the commercial sector and in academia. So augmented reality is arguably not reality capture, right? But I think it's really important to talk about it because for me, it is the interface between the data that we create and the data that we capture. And I think it's going to become the interface to get the insights out to the field. So those things that we're analyzing, that production that we're tracking, all those different insights that we get from the analysis tools after we capture the data, I think there'll be a time where we're going to start to see that information, displayed on the screen. What's the production, or how far is that done, or when is that going to be installed, that kind of thing. But the real thing that I want to talk about here is the perception of reality capture. I'm going to play a little video, but these guys are making it cool. This is a company called Red 6. I got introduced to this fairly recently, and I was just like, I have to show this to people. This is pretty amazing. They are using augmented reality to train fighter jet pilots. That's pretty cool. And I'm also seeing that people are starting to open up about this. They're starting to use it. It's losing its dorkiness. I'm tired of hearing people say, well, I don't want to put it on, or hearing in forums where people are saying, yeah, people don't want to put it on because they don't want to look dorky. That's Scott Moody. He's been in this business for 40 years. He's not worried about looking dorky. He's trying to get the job done. In this video, he's walking us around, telling us about the leave outs and the different things that need to happen on this job. Now, obviously, we can't see the model, but he can. And so he's kind of walking us through like, oh, we've got this piece of equipment, this valve. That platform that you see is actually a leave out because the equipment's so large that it's going to poke through the second floor and get its point of connection at the second floor mezzanine area. So, you know, talking to Scott, he doesn't have any reservations about, you know, using this tool. He wants to use the best tool possible, and I think that we got to look to folks like him, you know, to change that perception. The video on the right is just fun. That was just we were doing a video shoot to promote AR and talk about our use of it, and the video crew said, let's do a cut like I've seen on Instagram, and I was like, all right, I'm game. Let's go. So we did a little fun video, just to say, you know, again, trying to make it look different, you know, not dorky. I mean, I'm pretty dorky, but I'm trying. So following up on these industry trends, like what's the call to action? I think we've heard a lot about interoperability and infrastructure. I think we've really got to push for that. You know, we're creating a lot of data, and we've talked about that a lot throughout this conference, and we've got to figure out how to use that data, how to, you know, put it up to the cloud, or, you know, whatever the case may be. But I want to make sure that, you know, we push ourselves to continue that conversation about interoperability. Do we have the right file formats? Is there something new that's going to come out there? We've really got to push on that. One thing I'm really big on that I haven't heard a lot about in this conference is the conversations. We've talked about it when it comes to working with our clients, but I feel like we have to get more disciplined about this. And I've been guilty of it. And what I'm getting at is I want us to start talking about the use case first and not the technology. I look back and I recognize that I was running around talking about laser scanning. You need laser scanning. You need laser scanning. I was like Oprah, right? Everybody needs laser scanning, but nobody knew what it was, right? Or they might know what it is, but they have a perception based on what? A use case. And we've started this, we've got an early version of this, but we're trying to put a planning document together that starts with the use case, goes to the objective, and then figures out the best technology for the project. And I think we've got to flip that conversation and start talking about the use case of quality control, the use case of, you know, floor flatness as an objective, or the use case of documenting as-built conditions, and then figure out, okay, what is your objective for documenting those as-built conditions? And then based on that and the tolerances that you need, we're going to choose the right tool for the job. And then just a big one to say, you know, we've got to look beyond today's limitations and challenges. I think we get sort of pigeonholed in the idea that what we have is what we're going to have. And, you know, we're seeing consolidations, we're seeing, you know, different developments, we're seeing people come up with, you know, different ways of looking at the data. Somebody talked about, you know, compression, different things like that. So we've really got to, you know, visualize where things can be in the future. And I love going to conferences like this where we get to talk about this. But really, like, we've got to visualize what construction looks like when it's easier, it's less stressful, it's not scary. You know, we need to drive towards predictable results, right? And we're not going to get there if we're just, you know, looking at